Okay, so today we will start with the next bit, friction. So already all of you know that what is the friction. Okay, so before going further, let me know, do my voice is audible to all?
Yes, sir.
Okay.
Yes, sir.
Okay. So now we will move forward to the friction. Frictional force, you know, the force which is always act opposite to the motion is the frictional force. Okay, so if you are moving on the road with a vehicle, and if you suddenly you to see that if you won't give the accelerator, okay, if you won't accelerate, then after some time your vehicle will stop automatically without applying the brake. This is why, this is because of the frictional force, the frictional force between the tire and the surface, that will act in the opposite direction to the motion, and due to which the vehicle stops. This is a simple example of the friction. Okay, so to understand the friction more in detail, suppose now I will draw one diagram. Suppose now this is the surface. This is the surface. Now on this surface, a block is kept. On this surface, a block is kept like this. Okay. Now see, the centroid of the block may be somewhere here. Here is the centroid of the block. Okay, centroid. So through the centroid, the weight of the block is acting. So weight of the block is acting like this. This is the weight of the block W. Now instead of showing weight like this, what I will do, I will switch this weight like this. Okay, this is the weight W which is acting. According to law of transmissibility of force, you can move the force along its line of action within the body. So here, this is the weight W. Okay. And suppose this is my direction of the motion. So this is my direction of the motion. I will write here. This is the direction of the motion of this block. This block is moving in this direction. Now, in which direction the frictional force will act? So that the frictional force will act in the opposite direction, and that I can show this is the frictional force. This is the direction of the frictional force. Let us say that F is the frictional force. F is the frictional force. And now you can see the weight of this block is acting vertically downward on this surface. So to balance this weight, to keep this block in the equilibrium, you will get one normal reaction, and that reaction you will get from the surface, and that reaction is like this. So reaction from the surface is always perpendicular to the surface. Remember this. We will always show the reaction. This is R reaction, and this angle is 90 degree. This already we have seen in the case of spheres, the problems which we have solved previously in the Lami's theorem. In that we have seen this thing already. So this is the ideal diagram to see the frictional force. Now you can see over here that this is the direction of the motion. This is the weight vertically which is acting vertically downward. To balance this weight, this is the normal reaction R which is you are getting from this surface, and this reaction is always perpendicular to this surface. And in the direction of motion, the frictional force is in opposite direction to the direction of the motion. This is the frictional force. So here I can say that this W is equal to what? It is weight of body, or here in this case I can say weight of block. Then R is equal to what? R is equal to normal reaction. R is known as the normal reaction. Then F is the frictional force. F is the frictional force. Okay. One more quantity is here, that is called as mu, and this mu is called as coefficient. This mu is called as coefficient of friction. This mu is called as coefficient of friction. So suppose now the coefficient of friction between the surface of the block and this surface is mu. Suppose the coefficient of friction is mu. Then the frictional force, it is calculated as F is equal to mu into R. This is the formula to calculate the frictional force. Frictional force is calculated as F is equal to mu into R. Okay. So in this way, we are going to calculate the frictional force. So you can draw this diagram and write down all these things which I have already told you right now. And let me know when you complete it so that we will go to the next part. This is very simple thing. I hope now you understood this. Is it over? Is it over? Now we will see the definition of the friction. Okay, we will see the definition of the friction. What is exactly the meaning of friction? So whenever one body moves over another body an opposing force and an opposing force comes into play. An opposing force comes into play in common surfaces, or an opposing force, instead of this word comes into play, we can write here opposing force acts. An opposing force acts in the common surfaces. So whatever the surface is common between two bodies, okay, on that surface this frictional force is act. Okay, common surfaces of contact. Okay, full stop. This force which tends to oppose the moment of one body over another body is called friction. Okay, so whenever one body moves over the another body, an opposing force acts in the common surfaces of the contact. Okay, so here you can see when this block is now moving over this surface. Okay, so the opposite force, so this is the opposite force which acts in the common surfaces. So this is the common surface between these two. Okay, the force which tends to oppose the moment. So this force will try, this is the direction of motion. So this force will try to oppose this motion, okay, of one body over another body. So this type of force is called as the friction. This type of force is called as the friction. Next is the limiting friction. So the maximum value of frictional force, okay, this is the maximum value of the frictional force, it's called as the limiting friction. So you can remember this for MCQ. I'm not going to write that. Very little and simple thing is there. Limiting friction. Limiting means maximum friction. Okay. So limiting friction means what? The maximum value of frictional force along the common surface of the contact when when the body is just on the point of motion. Okay, so you can say that it is the maximum value of frictional force is nothing but the limiting friction. So now after this we will see classification of friction. Now we are going to see the classification of friction. So classification of friction. So basically friction is divided into two types. Okay. First is the static friction, second is the dynamic friction. Basically it is divided into two types, static friction and okay. Okay, so here this is first type is static friction and the second type is dynamic friction. Dynamic, or it is also called as kinetic. Kinetic friction. Dynamic or kinetic friction. So static friction is not further divided into any categories, but this dynamic or kinetic friction is further divided into two categories. It is sliding friction and rolling friction. So this, it is further divided into two categories. So we can show it over here. This is further divided into two categories. We will see each one by one. It is very easy. Single line definition is there for each friction. So now here it is further divided into sliding friction, and rolling friction. So now what is the meaning of this static friction? Now, what is the meaning of this static friction? So it is the frictional force experienced by the body when it is at rest. Okay, when it is at rest under the action of external forces. So when the body is at the rest, then whatever the frictional force experienced by the body is called as the static friction. It's called as static friction. Here you can see the formula carefully. What is the formula I have given to you? F is nothing but frictional force. F is equal to mu into R, where mu is the coefficient of friction and R is the normal reaction. So you can see that the frictional force is independent of the contact area. Okay, there is no area involved in the frictional force. So it is depending upon the coefficient of friction. This coefficient of friction value mu, it depends upon the roughness and smoothness of the surface. So this value of mu is depends upon the roughness, or how rough is the surface or how smooth is the surface. Depending upon that, this value of mu has a certain value. Then R is the normal reaction. This R depends upon the vertical forces, that is the weight. This R depends, the value of R is depends upon the weight or the vertical forces which are acting over there. So you can see that this F is depending upon these two quantities. It is not depending upon the area. So here you can see that in the static friction, even though if the body is at the rest, the body is not moving, but still the weight of the body is acting vertically downwards. So if the weight W is acting vertically downwards, you will get the normal reaction, which is perpendicular to the surface, and the body is resting on that surface is having some roughness. Okay, ideal smooth surfaces are not there, so there may be some value of the mu which we will get, So even though the body is at the rest, that body feels the frictional force. Okay. So the frictional force, it depends upon mu and r. So that is called as the static friction when the body is at the rest. Now the dynamic and kinetic friction means what? So it is the frictional force experienced by the body when moves over or within another body. Okay. So this is the kinetic friction means what? The frictional force experienced by the body when body is in the motion. When the body is in the motion, at that time, whatever the frictional force experienced by the body, this comes under this dynamic or kinetic friction. Further, this dynamic and kinetic friction is divided into two parts: sliding friction and rolling friction. The word itself tells you that what does it mean, sliding and rolling. There is difference between sliding and rolling. Okay, slide means it is slide over one another. Okay, it is slide over one another, and rolling means it roll. So if I tell you the definition of this, then the sliding friction is nothing but it is the friction experienced by the body when it slides over the another body or the surface. When it slides. Okay. And the rolling friction, it is experienced by the body when it rolls over the surface. When it rolls over the surface. So for the rolling friction, we can say that the friction experienced by the ball bearings. You can see the ball bearings are fitted in the cycle also. If you see the back tire of the cycle, the ball bearing system is there. Okay, so that will what we can say, in the minimum effort your wheel will rotate. So that type of mechanism it is fitted into the, even though in the cycle also ball bearing system, it is also in the bikes, two wheelers ball bearing system. Okay, so advanced ball bearing system is used in the four wheelers. So this type of friction, the body when it is rolling, or the simple thing is that समजा एखादा ड्रम आहे आणि तुम्ही तो ड्रम उतार आहे समोर आणि तुम्ही त्या ड्रमला धक्का दिला, आडवा ड्रम आहे समजा ठेवलेला, तर तो काय होईल, रोल होत खाली जाईल. किंवा एखादा बॉल आहे तुम्ही खाली टाकला ग्राउंड वरती, तर इट इज द एक्झाम्पल ऑफ रोलिंग फ्रिक्शन, इट विल रोल. ओके, so in this way these are the main types of the friction. Classification of friction: static friction, dynamic friction. Static friction, it is at the rest, the frictional force when it is experienced when it is at the body is at the rest. Dynamic friction, the word itself suggests that the friction experienced by the body when the body is in motion. Now again, dynamic friction is divided into two categories: static friction and rolling friction. Sliding friction and rolling friction. Sliding friction is when one body slides over the another body. Okay, that is called as the sliding friction. And the rolling friction is when one body rolls over the another body. Then the friction is experienced by the body is known as rolling friction. Okay, is it understood? So that we will write the definition of each. Yes, no?
Yes, sir.
Okay, so now we will write the definition of each term. So first is the static friction. Static friction. So it is the friction. It is the friction experienced by the body when it is at rest. When it is at rest, this is the static friction. Next is the dynamic or kinetic friction. Next is the dynamic or kinetic friction. This is static and this is dynamic or kinetic friction. It is the friction experienced by the body when it is in motion. When it is in motion. Next is the sliding friction. Sliding friction. So it is the friction. It is the friction experienced by the body or by the bodies when one body slides over another body. Okay, when one body slides over the another body. So example of this is when the shaft rotates in its bearing. Okay, when the shaft rotates in its bearing, it is nothing but the example of sliding friction. If I give the example of this, I can tell you that when a shaft rotates in its bearing. This is the perfect example of sliding friction. And lastly, we will see the rolling friction. Rolling friction.
Sir, sliding friction. Slide दाखव.
Okay. So write it now and let me know once you complete.
Sir, example काय आहे ते?
When the shaft rotates in its bearing. Shaft माहिती आहे तुम्हाला? आता तुम्हाला सांगायचं म्हणजे when you see a vehicle or a truck, जर तुम्ही ट्रक बघितली तर त्या पुढच्या चाकापासून मागच्या चाकापर्यंत एक आडवा रॉड लावलेला असते बघा. ओके, तर तो जो रॉड आहे ना, तो रॉड असतो त्याच्यामध्ये आतमध्ये एक शाफ्ट असतो, तो गोल फिरतो. That is called as shaft. That type of system is called as shaft. And these shafts are having the various uses. Okay, these shafts is used with bearings also. In the most of the times, these shafts are used in the vehicles or in the industries, automobile industries or various types of industries. When the shafts and bearings are fitted together, then the shaft is supposed to move in the bearing in circular motion. Okay. And when that shaft moves on that bearing is also moving up and down. So there is a sliding of that bearing over that shaft. Okay. So that type of so there the frictional force is getting generated, and this is the example of the sliding friction or the simple example of the sliding friction. तुम्ही जर पळत आलात एकदम जोरात, तुमच्या पायामध्ये समजा स्लीपर आहे आणि तुम्ही सरफेस वरती वाळू आहे आणि तुम्ही जर परत पळत आलात तर अचानक त्या वाळूमधनं तुमचा पाय काय होणार आहे, स्लिप होणार आहे. आणि त्यावेळी तुम्ही काय करणार, बॅलन्स करायला स्वतःला तुम्ही कसं तरी करून बॅलन्स करत स्लाइड होत पुढे येतात. सो दॅट इज द एक्झाम्पल ऑफ द स्लाइडिंग फ्रिक्शन. व्हेरी सिम्पल एक्झाम्पल इन अवर डे टू डे लाईफ. Okay, that is the sliding friction. When you slide, that is the sliding friction. So the next is the rolling friction. It is the friction experienced by a body when it rolls over the surface. त्याचं जर तुम्हाला मी उदाहरण सांगितलं that technically you can write that the ball bearings is the example, but the simple example, एखादा ड्रम आहे तो तुम्ही आडवा ठेवला. Okay, if you keep one drum horizontal and if you give the motion to that drum, so that drumची motion कशी होणार आहे? It will rotate about itself and it will move further. Or rolling friction, the simple example is the vehicle tires. It will roll along their circumference and then it will move further also. Okay, so this is the example of rolling friction. Okay, when one body is rolls on the surface, then what is the friction generated over there? That is called as the rolling friction. Okay, now further we will see the next definition is coefficient of friction. Coefficient of friction. Okay, so the coefficient of friction I have already told you. It is denoted by letter mu.
Sir, is it possible, sir? Is it possible to experience rolling friction and sliding friction at same time?
It is possible to experience
Rolling friction and sliding friction at the same time?
it is possible now. But what is happening? It depends upon the motion, which type of motion it is. But the thing is that, see, you if you experience static friction, dynamic friction, in that it may be rolling friction, it may be sliding friction. Your formula for the friction remains same. F is equal to mu into R. There is no change in the formula depending upon the type of friction. So whatever may be the friction, it doesn't matter what type of friction is getting experienced by the body. Once it is comes to the analytical part, when we supposed to calculate the value of that frictional force, there is only one formula, F is equal to mu into R. So even though the body experiences the two types of frictions or three types of frictions at the same time, then also we are going to calculate the frictional force by using the formula F is equal to mu into R. And it doesn't depend upon the type of friction. It does not depend upon the contact area. It only depends upon the coefficient of friction and normal reaction. Okay. So the body may be experienced what we can say, as you tell now, more type of friction at the same time. It may happen. It depends upon the type of motion carried out by that body. Okay, air friction is also one of the things that is not introduced in your syllabus. Air friction is there, aerodynamic friction is also there. So there are many types of frictions also. But here for your syllabus, just now we are studying these two main basic things we are studying. And in this way, there may be the question comes to your mind that if a body is experience the what we can say sliding friction as well as the body experience a rolling friction, it doesn't matter. जरी ती बॉडीमध्ये स्लायडिंग फ्रिक्शन आणि रोलिंग फ्रिक्शन दोन्ही ऍट अ टाइम जरी प्रोड्युस होत असले तरी सुद्धा तुम्ही फायनल ज्या वेळेला फ्रिक्शन कॅल्क्युलेट करणार तेव्हा फॉर्म्युला एकच आहे दोघांसाठी, एफ इज इक्वल टू म्यू इंटू आर. आणि जे काही आर ची व्हॅल्यू येईल, जी काही म्यू ची व्हॅल्यू येईल, त्याच्यावर तुम्हाला एफ ची व्हॅल्यू मिळणार आहे. तुम्हाला ह्याच्याशी काही देणं घेणं नाही की कुठल्या टाईपचं मोशन आहे, कुठल्या टाईपचा फ्रिक्शनल फोर्स आहे, काही नाही. ओके, सो it will not affect the value of the frictional force. What I want to say that if a body is experiencing more than one frictional force, means rolling friction and sliding friction at a time, if it is experienced by a body, then also there is no change in the analytical part of the frictional force. Okay, so now the coefficient of friction is our next definition. So this coefficient of friction we will see now. What is the coefficient of friction? So it is the ratio of frictional force to the normal reaction. So what the definition says, that coefficient of friction means it is the ratio of frictional force to the normal reaction. So now if I write here, this is my mu, coefficient of friction, it is denoted by mu. It is the ratio of frictional force F divided by normal reaction R. So mu is equal to F divided by R. Okay, you can also say that this your F is directly proportional, frictional force is directly proportional to normal reaction, because the value of mu is the coefficient of friction. The value of mu will be a constant value. Okay. So here you can say that to remove this proportionality sign, it is introduced a coefficient mu that is constant into R. So F is equal to mu into R. So therefore you can finally get mu is equal to F divided by R, where F is the frictional force and R is the normal reaction. So this is called as the coefficient of friction. This is the coefficient of friction. Okay. So the next is the angle of friction. Angle of friction. Next is the angle of friction. Okay. So the angle of friction, you can say that I will write the definition so you will understand very quickly. So the angle between normal reaction, the angle between normal reaction and resultant frictional force is known as angle of friction. So the angle between the normal reaction and resultant frictional force is known as angle of friction. Now I will tell you this by drawing a diagram so that it will be easier to you to understand. Now see, this is the surface. Now on this surface a block is there. This is the block. Now let us say that here somewhere there is center of this block. Here it is the center of this block. Now weight which will act vertically downward. So I will show the weight like this. This is the weight which is acting vertically downward, W. Okay. So to make sure that this will remain in equilibrium, you will get the normal reaction R. So this is the normal reaction R which you will get to balance this weight. So this is the reaction R. Okay. So here I will show this reaction like this along the surface. This is the reaction R. And now you can see I will draw the frictional force. So this is the frictional force. Okay, in this direction. Suppose the frictional force is, this is the direction of the frictional force. Okay. This is the direction of the frictional force, and normal reaction also I will draw here. This is the normal reaction. This is the normal reaction R. So this is normal reaction R and this is the frictional force F. And you imagine that motion is in this direction. This is the direction of motion. So frictional force is in opposite direction to the motion. But even though it is not in the motion, still the frictional force exists. I have told you about the static friction. So now here, if I complete the parallelogram, okay, here you can see if I complete the parallelogram over here, this is the frictional force which is in the opposite direction of the motion, and this is the normal reaction which balances the weight. And if I complete this parallelogram, the diagonal of the parallelogram gives me the resultant frictional force. The diagonal of the parallelogram will give me the resultant frictional force. Okay. So this is my resultant frictional force R. This is the resultant frictional force. So I will call this as FR, resultant frictional force, resultant of these two forces. And the angle which is subtended over here, let us say that this is phi. This angle is called as angle of friction, phi. So here you can see that phi is nothing but it is angle of friction. Phi is nothing but angle of friction. R is equal to what? R is the normal reaction. R is normal reaction. Fr is equal to resultant frictional force. Resultant frictional force. And F is equal to frictional force. F is equal to frictional force. Okay. So in this way, you can calculate this phi. Now here you can see this angle is 90 degree. This angle is 90 degree. Now if I talk about this one, now this triangle. If I talk about this triangle, so whatever I have drawn over here, this triangle, you can see that this triangle now. This triangle. Okay, so in this triangle, you can see this length. This is nothing but this is F, and this is R. This is R. Now in this triangle, if you use tan of phi, you know that tan theta is equal to what? Opposite side upon adjacent side. So the opposite side is F and adjacent side is R. Opposite side is this one, F, and adjacent side is R, because this FR is the hypotenuse. So I can write over here tan phi is nothing but F upon R. So tan phi is equal to F upon R. But we know that, but F upon R is nothing but it is mu. We have seen previously the formula for mu, coefficient of friction. So I can write here tan phi is equal to mu. Okay, so therefore phi is equal to tan inverse mu. This is also one of the formula. Okay, sometimes in the MCQ questions, they give you in single line the coefficient of friction between a body and a surface is 0.5. Then find out the angle of friction. In some MCQs they can ask you the question like this. Are you getting the question? The coefficient of friction between a block or the coefficient of friction between two bodies is 0.5. Then what will be the angle of friction? This type of questions can be asked in the MCQ also. So you should remember this formula. Phi is equal to tan inverse mu, or mu is equal to tan phi. You simply remember this also. You can remember this also. From this also you will get the same answer. ओके, आणि फॉर्म्युला कसा आला तर ते मी तुम्हाला सांगितलेलं आहे 2-3 स्टेप मध्ये. ओके, सो म्यू इज नथिंग बट द tan phi. So this is the angle of friction. This is what is the angle of friction. Okay, next important thing is that angle of repose. Next is angle of repose. Just 1 minute. Okay, so angle of repose, we will see now. What is the angle of repose? Now it is the minimum angle of inclination of the plane with horizontal such that the body on the plane just starts sliding down the plane under its own weight. Okay, so here I will tell you what exactly it means. Suppose now a inclined plane is there. This is the inclined plane. Okay, it is having some angle with the horizontal. Okay, so this angle, I will call this angle as theta. Okay, now suppose a block is resting over here. This is a block. Okay, so this is the slope. It is given like that. This block will just start to move downward. Okay, so this is the direction of the motion of the block. It will just start to move downward because of this slope, which is given at an angle theta. So here you can see this is the centroid. So the weight will act from the centroid vertically downward. So this is the weight. This is the weight W. Okay. Then you can see the normal reaction. Normal reaction will act like this. I will draw here the normal reaction N. So this is the normal reaction, which is always perpendicular to the surface. I have told you the reaction. This angle must be 90 degree. This is the normal reaction R. Okay. And if I show the frictional force over here, then the frictional force will be in this direction. This is your frictional force, which is nothing but F is equal to mu into R, the frictional force. So this angle theta, which is provided in such a way that this block will start to just move downward. Okay, it will start to move downward due to the slope. So this angle theta is called as the angle of repose. This angle theta is called as angle of repose. So this is theta, which is equal to, if you write the definition of this, so I will write it is minimum angle. It is minimum angle of inclination. It is minimum angle of inclination of the plane with horizontal such that the body on the plane just start sliding down, the plane. Just start sliding down the plane under its own weight. Okay. Without application of any external force. Without application of any external force. Full stop. Okay. It is denoted by theta. So this minimum angle is called as the angle of repose, and it is denoted by theta. Okay. So the simple example of this, तुम्ही जर सायकल चालवली असेल कधी, उतार आला एकदम, ओके, आता तुमच्या समोर उतार आहे, तुम्ही काय करता? आपण पायडल मारत नाही त्यावेळेला, तुम्ही उतारे म्हणल्यावरती काय करता, त्या उताराला तुम्ही आलात की तुम्ही पायडल स्टॉप करता, and that your vehicle starts moving downward automatically, your bicycle starts moving downward automatically. So the angle at which that slope is given, ओके, मग ती वर्टिकल डाऊनवर्ड कशामुळे चालली तुमची बायसिकल? कारण उतार आहे. उतार आहे म्हणजेच काय आहे नेमकं? सो द सरफेस इज ऍट सम इन्क्लिनेशन टू द हॉरिझॉन्टल. Okay, that surface is at some inclination to the horizontal. You can see over here. इथे तुम्हीच समजा बायसिकल घेऊन तुम्ही चाललाय सायकल घेऊन. Okay, so what happens? It will start moving downward because of this slope which is given over here on this surface. So it is given at an angle theta. Okay, and this theta angle it is given in a such a way that without any external force, म्हणजे तुम्ही पायडल मारायचं जरी थांबवलं सायकलचं तरी ती सायकल पुढे जाणार आहे. ओके, सो विदाउट एनी एक्सटर्नल फोर्स, तुम्ही पायडल मारता म्हणजे काय करता, तुम्ही एक्सटर्नल फोर्स देता सायकलला, सो दॅट सायकल विल मूव्ह फॉरवर्ड. ओके, बट इफ you stop pedaling the cycle, then also it will move further because of this slope. So without any external force means you are not applying any force and still the vehicle is moving forward. Okay, so if this case is there, then this angle, whatever the angle of inclination is there, this angle is called as angle of repose. This angle is called as angle of repose. Now one more important thing, see whatever I am telling. In the case of friction, okay, in the case of friction, when you apply the equations of equilibrium, summation fx0, summation fy0, summation m0, then first of all you need to see that on which surface the body is resting. Okay, on which surface the body is resting or it is moving. Now here you can see this block is there and this block is on this inclined surface. Okay, this block is here on the inclined surface. So this inclined surface will be your x-axis. This inclined surface is your x-axis and perpendicular to this is your y-axis. So here you can consider your coordinate system like this. This will become your x-axis and this is your y-axis which is perpendicular to this. Okay, so whatever you apply summation fx equal to 0, those forces should be resolved parallel to this plane. That is your summation fx. And the forces which are parallel to this vertical plane in this direction, this is nothing but your summation fy. Okay, and when the body is resting on this in this way, suppose now the surface is horizontal, okay, and if you keep the block as it is over here, this is the block, then in this case now, in this case, this surface which is horizontal, this is your x-axis normal, okay, and the perpendicular to this is your y-axis. So here in this case, this is your y-axis and this is your x-axis. So when you apply summation fx over there, the horizontal forces which are acting over here on this body, it will come under summation fx, and the vertical forces it will come under summation fy. In this case, this is the normal case when angle of repose is 0, when the inclination is 0. But when the body is acting on an inclined surface, it is resting or moving on an inclined surface, then in that case this inclined surface will become your x-axis and perpendicular to that your y-axis will be there. How to solve these problems, that we will see later on. Just see that how we are going to solve the numericals. Okay, so inclined plane will become x-axis and perpendicular to that is your y-axis. Now I will erase this. Okay, now see here. See here. If this angle is theta, then this angle is also theta, angle between these two. This angle is also theta. How it can be theta? I have told you one theorem in the first lecture. Angle between the lines is angle between their normals. Angle between the lines is angle between their normals. Now here you can see this angle theta, it is subtended between these two lines. This is one line and this is the second line. So if you see weight is acting always vertically downward and it is always vertical, W, and this line is horizontal line. So the angle between these two, it is 90 degree. This angle is 90 degree. Okay. Again, the second thing is that, so this W is perpendicular to this line, this horizontal line. And now this is the inclined surface. So the normal reaction is always perpendicular to the inclined surface. Normal reaction is always perpendicular to the inclined surface. So if म्हणजे काय बघा, या हॉरिझॉन्टलला W परपेंडिक्युलर आहे आणि ह्या इन्क्लाइंड प्लेनला R परपेंडिक्युलर आहे. मग जरा इन्क्लाइंड प्लेन आणि ही हॉरिझॉन्टल ह्यांच्यातला अँगल थिटा असेल तर या दोघातला अँगल पण किती असायला पाहिजे, थिटा. इट इज अकॉर्डिंग टू द थेरम. Angle between the lines is angle between their normals. Okay. Now if you observe carefully, now my x-axis is not horizontal and my y-axis is not vertical. Now my x-axis is this inclined plane. This is my x-axis and perpendicular to that is my y-axis. Okay. Now if you observe this R is parallel to this y-axis. This R is parallel to this y-axis. And if you observe the frictional force F, this is parallel to this x-axis. Okay, the frictional force F, it is parallel to this x-axis and this reaction R, it is parallel to this y-axis. Now, if you observe W is not parallel to x, it is neither parallel to x, not parallel to y. So we need to resolve this force W according to this our new plane x and y. So if you resolve this W, you will get one component. So I will shift this R upward now. So this is my R. Okay. I will shift this R upward. Okay. So this angle is theta. This is already known to you. So now if I resolve this W into two components, so the first component will be parallel to X. So in this way, and the second component will be parallel to Y. So which will be in this way. This is the second component. Okay. So this is my W cos theta and this is W sin theta. If you resolve W cos theta and W sin theta, if you resolve this. Now if I apply summation Fy equal to 0. Now here if I apply summation Fy equal to 0, what do I get? Now Y is this axis. Huh? The forces parallel to this axis you should consider in Fy. So R is there, R is moving vertically upward, so plus R and minus W cos theta. Now don't consider this W as we have got two components of W. So consider these two components for the further calculation. So here, if you apply that, then what you will get? You will get R minus W cos theta is equal to 0. So therefore, R is equal to what? R is equal to W cos theta. This you will get. Okay, this you will get. Now similarly, if you apply summation Fx equal to 0, if I apply summation Fx equal to 0, then what do I get? If I apply summation Fx equal to 0, now this is my x-axis. The forces parallel to this plane that I should consider. So F it is moving towards right, so it is positive. Then minus W sin theta. So W sin theta, it is moving towards left, so it is negative. So I can write here F minus W sin theta is equal to 0. Therefore, F is nothing but, what is the formula for F? F is equal to mu into R is equal to what? W sin theta. Mu into R is equal to what? W sin theta. So therefore, what is the value of mu? Therefore, mu is equal to, it is W sin theta divided by R. W sin theta divided by R. Okay. So this is the value for mu, W sin theta divided by R. So if you divide this equation, what we can say, equation 1 and equation 2. If you divide equation 1 and equation 2, what you will get? W sin theta divided by W cos theta. Okay, so W will get cancelled. Sin theta upon cos theta will be tan theta, and tan theta is equal to mu. That you will get. Okay, So suppose now I will say that this is my equation 2. Now divide equation 2 by equation 1. If I divide equation 2 by equation 1, so equation 2 mu into r divided by r, which is equal to w sine theta divided by w cos theta. So this r will get cancelled, this w will get cancelled. So what you will get, therefore mu is equal to what? Tan of theta. So this is the formula you will get over here. Mu is equal to tan of theta, where theta is the angle of repose. Where theta is the angle of repose. आणि मगाशी जे बघितलं होतं ते काय होतं? अँगल ऑफ फ्रिक्शन होता. त्याला नोटेशन काय होतं? फाय होतं. मगाचा जो अँगल होता म्यू इज इक्वल टू tan फाय. That is angle of repose. And theta is equal to that is angle of friction, and theta is equal to nothing but it is angle of repose. Okay, so finally I can say over here the tan of theta mu is equal to tan of theta, which is equal to tan of phi, which is equal to tan of phi, where theta is equal to angle of repose and phi is equal to what? Angle of friction. Angle of friction. So what conclusion I will get over here, that if a body is on an inclined plane, okay, and it is in motion due to its own weight, then angle of repose is equal to the angle of friction. Then angle of repose is equal to the angle of friction. Here you can see, when a body is in motion due to its own weight, म्हणजे हा वेटचा एक component इकडे येतो w sin theta, and this component will try to move the body in this direction. Okay, so when a body is in motion on an inclined plane due to its own weight, then your angle of repose is equal to the angle of friction. Your angle of repose is equal to the angle of friction. That is the thing. So this is called as angle of repose. So in the angle of repose only I have taken the further part. Okay. So I think today this much of theory is enough. In tomorrow's lecture, we will take the laws of friction, okay, and then we will start the numericals. So today we will stop over here.
तर इक्वेशन 1 ची व्हॅल्यू इक्वेशन 2 मध्ये ठेवल्यावर काय होईल?
काय झालं?
इक्वेशन 2 मध्ये जर इक्वेशन 1 ची व्हॅल्यू पुट केली,
हा, इक्वेशन 2 ला इक्वेशन 1 ने डिवाइड केलं. सो LHS ला LHS ने डिवाइड करणार आणि RHS ला RHS ने डिवाइड करणार ना तुम्ही.
r ची व्हॅल्यू जर इक्वेशन 2 मध्ये ठेवली तर आन्सर येईल. ठीक आहे.
काय झालं?
इक्वेशन 1 जर इक्वेशन 2 मध्ये पुट केला तर
मग एकूण एकच येत आहे ना, कसंही करा तुम्ही, तेच आन्सर येत आहे. इथं r च्या ऐवजी इथं w cos theta येणार, ते तिकडे जाऊन डिवाइड होणार, म्हणजे शेवटी तुम्हाला हीच टर्म मिळणार ना. At final you will get the same thing. By whatever mean you are doing, you will get the same answer. Okay, you will get the same answer if you put r is equal to w cos theta over here. So mu into w cos theta is equal to w sin theta. When you send that w cos theta to that side, it will go to the denominator. It will automatically become tan theta. Mu is equal to tan theta. You will get that. Okay. Okay. So now give me the attendance. Roll number 1.
Present.
2. 3. Roll number 3. 4.
Roll number 2 is
5. 5 is present. 6.
present, sir.
7. 8.
Present, sir.
9.
Present, sir.
10. 11.
Present, sir.
12.
Present.
13. 13. 14,
Present, sir.
15,
Present, sir.
16,
Present.
17,
Present, sir.
18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22, 23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26. Okay, 26 is present. 27,
Present, sir.
28, 29,
Present, sir.
30,
Present, sir.
31, 32,
Present, sir.
33,
Present,
33,
sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37, 38,
Present, sir.
39,
Present, sir.
40, 41,
Present, sir.
42, 43,
Present.
44, roll number 44, 45, 45, 46,
Present, sir.
47, 48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51, 52,
Present, sir.
53,
Listen, sir.
54,
Present, sir.
55,
Present, sir.
56, roll number 56, 57,
Present, sir.
58, 59,
Present, sir.
60, 61, 'Okay, so I will call the absent number once again. If you are present, you can tell me in the chat or by unmuting yourself. Roll number 3, 10, 18, 42, 44, 47, 51, 56, and 60 are the absent roll numbers. Anybody who is present from these roll numbers? Okay, so today we will stop over here.
सर आपली टेस्ट होणार आहे त्याच्यासाठी MCQ रेफर करायसाठी
काय झालंय?
उद्याची टेस्ट आहे त्याच्यासाठी आम्हाला थोडे MCQ पाहिजे होते रेफर करण्यासाठी.
त्या दिवशी मी शिकवलेत की तुम्हाला MCQ तेच रेफर करा.
सर ते 40-30 तेवढं
हा मग त्यावेळेला नाही का काढले तुम्ही स्क्रीनशॉट किंवा काय लिहून नाही काढले?
काढले.
हा मग ते रेफर करा.
ओके सर.
ओके.
किती वाजता टेस्ट आहे?
टाइम किती टेस्टचा?
I am not able to hear you. Can you repeat once again? परत एकदा सांगा काय म्हणत होता?
सर टेस्टचा टायमिंग किती आहे?
टायमिंग आता उद्या रविवारच आहे ना, तुम्हाला सांगतो की मी ग्रुप वरती टाकतो तरी मी उद्या रविवार आहे ना, 11 वाजता देईन तुम्हाला टेस्ट. 11ला चालू करा. 11ला एकदा ग्रुप चेक करा.
येस सर.
ओके ठीक. उद्या काय लेक्चर नाही तुमचं एक्स्ट्रा वगैरे कुणी काय ठेवलेलं? ठीक आहे. ओके.
सर
आवाज येत नाही तुमचा.
58% आहे म्हणले सर.
You come in the proper range. I'm not able to clearly hear your voice.
सर 58 प्रेझेंट म्हणलो.
58 ला मी
Hello.
absent मध्ये तू ऐकलं नाही का? अटेंडन्स घेताना तुम्ही ऐकलं नाही का? मी काउंटच केलं नाही ना absent मध्ये 58 ला. कधी सांगितलं का मी रोल नंबर?
फोन आलता.
हम्म?
फोन आलता सर. फोन आलता.
अहो मी तुमचं रिझन विचारतच नाहीये. मी काय सांगतोय, मी जेव्हा absent नंबर सांगितले तेव्हा मी तुमचा रोल नंबर घेतलाच नाही. सो पे अटेन्शन. ओके चला सर, आय विल लिव्ह नाव.